Okay, so you guys just left, and I had promised that I would do some video and explanation of some problems that you had questions on and get you prepped for your work tonight. And the first problem that I want to share with you and discuss is number 22 on page 704. In 22, the question is asking us to explain the meaning of statistically significant at the 5% level, and the student explains it in error. The student explains it as that this means the probability that the null hypothesis is true is less than 5%. Now, our p-value does not speak to the likelihood of the null hypothesis. Our p-value speaks to having a sample resulting with the test statistic and p-value given if the null hypothesis is true. So if you need to, take a minute to absorb what I'm saying, and then what I have written here, pause your video if need be to take a second and articulate your response to that. Now, I'm going to move forward into problems 27, 31, and 32, and take a little bit more time with these. I am going to get started on 27, page 709. If you're not there, get there. And what I find out when I read problem 27 about water quality is that we have, and I've got some of just the stats I want to pull out of this. We have a sample of size 45. I'll need that later to make an adjustment to my standard deviation. I have a, let's see here, a mean from my sample of size 45 resulting in 4.62. I am also told that we expect the level to be at 5 with a standard deviation of 0.92. Now, before I go any further, I'm going to stop and just quickly write out my null, expected at 5 versus my alternative. And given that I've got a sample less than, I guess I'm arguing that the mu is less than 5. So this will come up. I need to use the Inference Toolbox, which means I need to go through the 4-step process. First of all, I need to define the parameter and the population of interest. We're interested in finding the mean amount of dissolved oxygen in a stream. Specifically if it's less than 5. Now, because it's always important to pay attention to our units in terms of precision, it's in milligrams per liter. Milligrams per liter. Milligrams per liter. Got to remember that this always has milligrams per liter. A context. Now, actually, it's probably a good thing that I've got my null and my alternative here, because I need to talk about this in step 1. I need to write out what it is, and then I need to state my null and my alternative. Now, we will use a z-test because we're given this, and I'm going to say using a z-test as we have a known population standard deviation, as we have a known sigma. Boy, I hope I'm talking loud enough, because when I've done this before, I haven't been talking loud enough, particularly when I have an empty classroom. Now, we will need to next, this is define the population and parameter of interest for our Inference Toolbox. So Inference Toolbox step number 1. Inference Toolbox step number 2 leads me to talk about my conditions. The sins, the 3 deadly sins. First of all, we can use our test because we are told that this sample of size 45, we're going to assume that our 45 samples were taken from random places through the stream, along the stream. I'm honestly, when I go on to talk about independence, so my SRS, my independence, I'm kind of struggling here. I'm not sure it's safe to assume independence because what's going on in the stream and the way the stream flows, I'm not sure if it's safe. I'm going to say that. I'm going to proceed with reservations. Here's something I'll say. I will proceed with caution. If you're taking up 1 or 2 lines to talk about the preconditions, probably not enough. Real detail. And last but not least is normality. Is it normal? And I don't remember reading that we were told it was normal, but no, I don't see the word normal there. Based on the sample size of n equals 45, we'll assume that the central limit theorem applies. Sample size of n equals 45, we will assume that the central limit theorem applies. Again, we ran into the central limit theorem, I believe, in chapter 9. So inference toolbox number 2. Now I have to go on to my inference toolbox number 3, and that is doing the calculations. My z-test statistic. Glad I wrote all this stuff down over here. 4.62 minus 5, all divided by 0.92 divided by square root of 45. I have this calculation done in advance. You're welcome to stop and check my math. Makes sense that it's a negative z-score since the sample mean is under, but I expect it. And so now I have to find the p-value by finding the probability that the z is less than. And remember, my less than comes from the direction of my alternative, negative 2.77. I'm going to draw myself a quick sketch, understanding that this is going to be a pretty low p-value. Because when I go over, and I probably would even draw it further over, when I go over to negative 2.77 and use my pink table, I get 0.0028%. So the probability under the curve related to that is 0.0027. That would give me a p-value of 0.27%. Now, in this question, have we been given any, is this strong evidence? Now, I know I had mentioned in class today that we assume statistical significance at, if it's not given, at 5%. When I go into my inference toolbox number 4, I need to wrap this up, and I need to say that the p-value with a resulting p-value, this is a summary, the step 4 is a summary, with a resulting p-value of 0.27%, we can reject the null hypothesis at any level of significance. And I say that because levels of significance are going to be 1%, 5%, 10%. This is less than 1%. The mean amount, this means that the mean amount of oxygen at 5%, I'm sorry, at 5 milligrams per liter as expected cannot be true if we have a sample result like we do happening only 0.27% of the time. If they said it was true, we should, if it is true, we should have samples that would happen way more frequently than less than 1%. So the inference toolbox, that was the important thing there, is going through that entire process for the inference toolbox. I'm going to move on to problem 31. And problem 31 is on page 712. And now when we get into 31, we start looking at that whole connection between confidence intervals and significance tests. I mentioned the connection in class today, significance tests and confidence intervals. So in 31, what I'm looking at is dealing with a null hypothesis that says something about a mu of 10. And then I'm getting a p-value related that is at 6%. Now, here's the thing. Letter A. Does a 95% confidence interval include 10? Now, the thing about this is if I've got a 95% confidence level, a 95% confidence level is going to go along with a 5% significance level. In this case, with a p-value of 6%, I fail to reject the null, and since I can't reject the null hypothesis, it must mean then that 10 is in that 95% confidence interval, which implies that the mean of 10 would be included in the interval. Now, without me writing up everything related to B, does a 90% confidence interval include 10? If I'm at a 90% confidence interval, that's going to be a 10% significance level. I have a p-value of 6%. In part B, I would reject the null because my p-value of 6% is under the 10% confidence level. And so if I am rejecting the null, it is safe to assume then that that mean of 10 is outside of my 90% confidence interval. What they're saying is it should be 10. My sample is telling me otherwise, which means that the corresponding interval would not contain the expected mu of 10. Now, when I go beyond 31 and I look at 32, confidence intervals and significance tests. Now in 32, take a minute and stop and finish your 31 if you need to. 32, CIs and significance tests. What I'm given in this is a 95% confidence interval that looks like 31.5 plus or minus 3.5. This interval would center at 31.5. Its endpoint would be at 35 if I add my 3.5, and over here would be at 28 if I subtract my 3.5. So, you know, your margin of error determines the distance between your sample mean. Can you reject the null hypothesis? All right, so now we have the information that the null is that the mu is 34, and we have 5% significance level. My first question in A is, can we reject the null at 5%? And 34, that sample mean is actually in this 95% confidence interval. So since the mu, 34, is contained in the 95% confidence interval, is contained in the 95% confidence interval, we fail to reject at a 5% level. Now, In part B, the mu changes. And I'm not going to write up the answer to part B. I'm going to allow you to do that, following up with what I have here. And in part B, the answer, the mu given, the expected mu is 36. Draw a conclusion based on the fact that the expected mu of 36 is not contained in this 95% interval. So we would be able to reject a mu of 36 since it sits outside the interval. I'm going to stop there and assume that if you're taking the time with this, that this has helped to improve your understanding. Good luck.